Hello everybody, we are continuing this lesson today from what we left off with on Friday last week, in which we were looking at samples that were randomly assigned to two different groups. We were finding the mean of each group and looking at the difference between those means. We need to start today looking at whether or not the differences could be considered something significant or something that occurs by chance just in assigning groups randomly. So I would like you please to take a look at the warm-up. I'll give you 3 minutes on this. This is really a review of what we did on Friday. So if you get stuck, pull out your notes from Friday and start looking those over, and you'll see this warm-up should look very familiar. So let's give you 3 minutes on that. All right, let's see what we've got on this thing. We have a dot plot which is showing us difference between mean values. So this difference here, I want to make clear, is the difference in mean values from group A to group B. And in this distribution on Friday, we gave an estimate of the center or mean to be about 0. For those of you that like to know the precise values, I will tell you that although we use the approximate center to be 0, the actual mean, just for those of you who like to know, and this is for all 250 points, actual mean is slightly left of 0 at negative 0.53. And that is a difference in ounces for the tomatoes that we were looking at on Friday. All right, then we went and we looked at, well, what's the probability of getting a difference value that is 1.64 ounces or more? And we said on Friday, and if you count again, looking at 1.64, there are 17 points or differences that are 1.64 ounces or more. And that's out of 250 total, so we said the probability of that happening, 17 over 250, about 6.8%. Similarly, for a difference that is a negative 0.8 ounces, we said there were 69 that were that small a difference or less, and that's out of 250 total, for a percentage of about 27.6%. We also said on Friday that if a treatment was not effective, we would expect the difference in means, or that diff value, to get close to zero or be very small. So we want to start looking at that today and see if we can figure out, well, is our percentage difference something that is statistically significant, or is it something that could be due entirely to chance and random assignment? So turn your page if you would, please. Keep in mind these points here that we made on Friday. And on your next page for notes, we have that same dot plot again, where we have 250 difference values that were computed. And this is again based on our tomato experiment, where out of 10 tomatoes, 5 were treated with some kind of nutrient. So we want to again write down what is going on with these differences, but before we do, there's some things that we should make sure we understand. I'm going to write those down in a column over here. If a treatment was not effective, then we are expecting our difference value, that diff number, to be very small or about equal to 0. That means that if we get something close to 0, I'm trying to write it, think at the same time. If we get something close to 0, we're going to say that the treatment likely not effective. However, keep in mind that some differences occur just by chance. If our difference is what we would call extreme or far away from 0, so now I've got another case here. If our diff value is something more what we're going to call extreme or far from 0, then maybe it's statistically significant and not due to just chance. So we're going to say maybe the difference is not due to chance occurrence. Maybe it is due to treatment. we are going to say that this is an extreme value if we say it is statistically significant. So I'm going to add that here. An extreme quote-unquote difference is a statistically significant difference. All right, you want to keep all that in mind and at the same time go and look at these numbers that we have on the left-hand side of our notes. So, would we consider 1.64 ounces to be significantly different or statistically significant? Let's underline that phrase, statistically significant. So what I'm going to say here is that we said the possibility of 1.64 ounces or more occurring as our difference. This happens about 6.8% of the time, has a 6.8% probability of occurring. I'm going to say that's not very frequent. So it is possibly statistically significant. In other words, it doesn't happen that frequently, so if it does, it could be statistically something significant. It could be that it's due to treatment. Something like the negative 0.8 ounces. Well, this thing occurred, we found, about 27.6% of the time. Just due to chance. I'm thinking that's enough of an occurrence that it may not be statistically significant. And on Friday, we looked at the probability of something occurring within 0.8 ounces of a zero difference. And we said that this occurred, and you can get this from your notes on Friday, about 48% of the time. Just in random assignment. So if that's happening that often due to chance, probably not statistically significant. Okay, so we're going to turn the page and we're going to take a look at what is happening with some of our other values here. So going to my next page, I can get this thing to go. Here we go. So we looked on Friday at some other difference values. We had one that was 2.44 ounce difference, we had 0, and we had a 0.28 for some 3 different values. Would we consider those to be significantly statistically significant? So let's first look at, I want to pick this large value here, 2.44 ounces. The probability of getting a difference of 2.4 ounces, well, I want to look at how often did that occur. So I go back to my dot plot. I'm going to go back page, look at my dot plot, 2.44, that occurred one time out of my 250. So the probability of that happening once out of 250 random assignments is going to be about equal to 0.004, or as a percentage, 0.4% of the time that that occurs. Not very often at all. In fact, I would say this is a rare occurrence. So that means if it's occurring rarely due to chance, it is statistically significant. And possibly due to treatment. Okay, if I look at the 0.28 and the zero difference, those are occurring much more often. So those are more likely to be occurring by chance and are not statistically significant. So this 2.44 that occurs 0.4% of the time, that is our statistically significant occurrence. All right, now that difference value is the mean weight for my group A tomatoes minus the mean weight of the group B tomatoes. So if I have a value 1.64, and this is really just review of what we did on Friday, this means that the average weight of a tomato in group A is 1.64 ounces heavier than the average weight of a tomato in group B. Alright, so now we're going to look at the implications of these values. So if you would, take a moment please and read through these sections here. I'll give you a minute to do that reading. Alright, I want to make sure we highlight some things in this reading here. We are looking at our observed difference. We are going to say if it is an extreme number or not typical of chance behavior, then maybe it is statistically significant, possibly not the result of chance behavior, so possibly not chance behavior. If this thing, though, is something that is significant, then we're going to say if that difference did not happen just by chance alone, maybe it's caused by treatment, and this is still a maybe. Maybe caused by treatment. In this case, or our tomato example, that would be the nutrient. Okay. All right. Let's go then take a look, going on to your next page. We're going to take a look at some difference values, and we're going to decide or make a statement about what we think, whether or not this is something that is statistically significant or not. So we're going to take these difference values, 0.4, 0.8, 1.2, 1.6, 2.0, and 2.4. And we're going to look at how often did these occur out of our 250 simulated random assignments. So I want to know how often did each occur out of our 250 random assignment simulation. So, difference of 0.4. I calculate that that occurred when I counted 91 out of 250 times, which is about 36.4% of the time. I'm going to say this is not something that is rare, therefore not statistically significant. All right, I'm going to let you have some time to look at the rest of these, and then we'll share what we've got. So take a couple minutes, please, and calculate 2, 3, 4, 5. Okay, hopefully that you are getting these same numbers and values. If not, I'm hoping that you're not more than 1 or 2 dots count off from what I have. And some of you are probably wondering, well, what is considered rare? What is not so rare? What would be statistically significant? And here's a rule of thumb you could use if you really want some number boundary. In this difference of 1.6, I'm getting 11 out of 250, which is occurring 4.4% of the time. You could use a 9% or something a little smaller as your boundary. 4.4 definitely less than the 9, so we're going to say this is, maybe it is statistically significant. It is at least a little more of a rare occurrence. So we are going to, I hate to use these imprecise terms, but we're going to say it's more rare. So we can say then that this is a statistically significant difference. Use our battery here. Okay, continuing on, we're going to say that this is a statistically significant difference. For the fifth one here, 2.0, I show that occurred 3 out of 250 times, about 1.2%. Definitely something that is rare. We're going to say that this is statistically significant. And number 6, this 2.4 we did previously. And I think we got, oh, maybe we didn't. I'm sorry. This one is 2.4. 2. Same kind of number here. So I'm going to go with 2.4 is 2 out of 50. So I'm now here at number 6. 2 out of 250. You're going to see if 3 out of 250 is rare and statistically significant, we're going to say that this one is also statistically significant. So if I get differences like this, then if they're statistically significant, then these 3 anyway, likely due to treatment or possibly due to treatment. Okay, we did some figuring on Friday. We got a difference value of 0.28 ounces, and I would like you now to go through and decide whether or not that is a statistically significant number. And then on the next page, we also got on Friday a value of 2.44 ounces. I'd like you to figure out whether or not that was statistically significant. I'll give you a few minutes on that, and then I will write in an answer so you can complete the notes. However, please do this on your own and only look at what I have written down as a check. When you're done with that, you're ready for the homework, and I hope that I will see you before the end of class, but if not, have a great day, everybody. Thank you.